Math 175, lesson 11. Today we do the chain rule. But before I start, as always, I'm happy to answer questions, do homework problems, whatever you prefer. Are there any questions? Anything I should go over from the homework? Can you hear me now? Okay, good. So if there are no questions, let's start with section 3.4 on the chain rule. And this is the last topic that's covered on the first exam. We'll have a review on Wednesday. Monday of next week, CUNY is closed for Columbus Day, and the exam will be a week from Wednesday at 9 o'clock. And I will post the exam on the assignments part of Blackboard and also email it to you. You will write out the solution to the problems, convert it to a PDF file, and upload it to Blackboard. So it's exactly the same process that you've been doing with your homeworks. So there should not be any difficulty. But if you have any problems or any questions, you will let me know. Okay. So the important thing is the idea of a composite function.
Professor.
Yes.
Please, are we doing lesson 10 or lesson 11 today?
Lesson 11.
Okay. Thank you.
We did lesson 10 last Wednesday.
Oh.
Okay. Lesson 11. So a composite function is when you have two functions and you apply one and then you apply the other. So imagine you have some function g and you put in a number x, and out comes a number g of x, which we might call u. And this number that comes out goes into another function f, and what comes out is f of u, or f of g of x. So if you start with x and you end up with f of g of x, this is some function we call the composite, f composed with g. So you have two functions, f and g. You do one and then you do the other. So what's our, some simple examples? Suppose we have the function g of x equals x plus 1. And f of u is 1 over u. So if we compose them, f composed with g of x, this means f of g of x. G of x is x plus 1. And f of anything is 1 over that anything, 1 over x plus 1. So f composed with g of x is 1 over x plus 1. That's an example of a composite function. Or another example is, suppose we have g of x is 3x squared minus x plus 1. And f of u is the square root of u. So if you compose these, f composed with g of x, this is f of g of x. What is g of x? 3x squared minus x plus 1. What is f of anything? The square root. So this is, we can view this as a composite function. And the idea is both of these two functions are rather simple. This is just the square root of u. This is just a quadratic polynomial. The composite is more complicated. And if you want to differentiate a complicated function, it's very useful often to be able to decompose it into a composite of two much simpler functions. And how do you do that? Well, skill and practice. You just develop an ability to see a complicated function as a composite function by having done a lot of examples and a lot of homework problems. Right? It's not that there's a simple rule that says how to do it. It's a technique to acquire. And the chain rule is a rule to differentiate a composite function. So this is the chain rule. The chain rule is to differentiate a composite function. And the rule, I can write it down in two ways. If you have the composite function f of g of x, and we differentiate this with respect to x, that is, it's the derivative of f just use a prime as the notation for a derivative. This is the derivative of f evaluated at g of x times the derivative of g of x. And an easy formula to remember the rule for the chain rule is if y is some function of u and u is some function of x, then the composite function dy dx, so you can think of this almost as a fraction. This over this is like dy over du, du over dx. Imagine like these cancel, this is what you get. So this is really just a great way to remember the chain rule. If y is a function of u and u is a function of x, dy dx is dy du times du dx. Right? It's almost like a fraction. And before I prove it, let me work out a number of examples. So in the book, in edition 5 at least, this is example 3. We have the function y equals x squared plus 1 cubed. We can think of this as a composite of two functions. You could have y is a function of u, which is u cubed, and u is a function of x, which is x squared plus 1. So f of g of x is f of x squared plus 1, and f is the cubing function, x squared plus 1 cubed. So the first step is to see how to decompose this as a composite function. If y is u cubed, dy du is 3u squared. If u is x squared plus 1, du dx is 2x. So by the chain rule, dy dx is dy du du dx. dy du is 3u squared. Du dx is 2x. So this is 6xu squared. But what is u? X squared plus 1. We want an answer which is just in terms of x. So 6x times x squared plus 1 squared. That's the chain rule. Other questions about this? All right, let me explain it again. So I'll do it on a fresh piece of paper. So we have the function y equals x squared plus 1 cubed, which we can think of as u cubed, where u is x squared plus 1. So this slightly complicated function is really the cube of something which is simple. So this suggests we let g of x equal the function x squared plus 1 and f of u be the function u cubed. So we're going to let u be equal to x squared plus 1 and y equal to u cubed. And again, if we take this composite, so y is f of u, which is u cubed, and u is x squared plus 1 cubed. So this is exactly the function we've started with, but this is the composite f of g of x. Right? Is there a question? Any questions about this? This is the first step. This is before we get to use the chain rule. This is just decomposing this function as a composite function. So if y is u cubed, if we differentiate y with respect to u, we get 3u squared. And if u is x squared plus 1, when we differentiate u with respect to x, we get 2x. So dy dx, now this is the chain rule. Is dy du du dx. dy du is 3u squared. Du dx is 2x. So this is 6x u squared. What is u? X squared plus 1. That's the answer. Let's check this. First of all, let's just check this. Let's expand this. So this is 6x, and when you square this, you get x to the 4th plus 2x squared plus 1. So this is 6x to the 5th plus 12x cubed plus 6x. That's this expanded. Okay? Let's check. The reason we can check is that the function we started with is not that complicated. It's x squared plus 1 cubed. Right? So y, which is x squared plus 1 cubed, if we expand this, and we're supposed to know at this point how to cube something, this is x squared cubed plus 3x squared squared plus 3x squared plus 1. That's x to the 6th plus 3x to the fourth plus 3x squared plus 1. So if we differentiate this directly, dy dx is 6x to the fifth plus 12x cubed plus 6x. And you see, they're exactly the same. It checks. So we can have some confidence in the chain rule. Questions about this? Okay, good. Now there's one case of the chain rule.
I'm sorry, Professor. So you want us to break it down to the very end like that doing the test?
No, this is all you have to do. I mean, this is the answer.
Hello?
This is the answer. This is the answer, because they're equal to each other. The check, you're not required to do. What you're required to do is somehow, it's up to you, solve the problem and show the work.
Okay. My other question is, on the exam, are there going to be multiple choice, or are we going to have to work this out and how we're doing it?
You're going to work it out and show your work. It's not multiple choice.
Thank you.
Okay.
By the way, what problem is this one?
Sorry, is there another question?
What problem is this one in the textbook? The homework question, is it?
This is not a homework question. This is an example of the chain rule.
Okay.
Let's look at another example. Suppose we have the function y equals 3x minus 2x squared cubed. So if we were to let u be a certain function of x, 3x minus 2x squared, and y to be some function f of u, which is just u cubed, then this is exactly 3x minus 2x squared, g of x cubed, which is f of g of x. So I've decomposed this function as this composite. If this is u is 3x minus 2x squared, du dx is 3 minus 4x, and dy du, if I differentiate u cubed with respect to u, that's 3u squared. So by the chain rule, dy dx is dy du, du dx. dy du is 3u squared. Du dx is 3 minus 4x. What was u? 3x minus 2x squared. So this is